The P0005 code indicates an open circuit in the control system for the fuel shutoff valve A. This valve is crucial for regulating fuel flow, and an open circuit means the ECM isn't receiving the correct signal, preventing it from operating the valve properly. This is most commonly seen in older Ford Power-Stroke diesel engines like the 6.0-liter and 6.4-liter models. When the P0005 code is triggered, you might experience several issues. These include engine stalling, reduced engine performance, difficulty starting the engine, or even a complete no-start condition. These symptoms arise because the fuel supply is not being controlled as intended. Several factors can lead to a P0005 code in Ford diesel vehicles. The most common causes include corroded connectors and wiring, a failing fuel injection control module, and damaged wiring harnesses. Corroded connectors and wiring are frequent culprits, often caused by moisture exposure or age. This corrosion increases electrical resistance, creating an open circuit that prevents proper valve control. A failing fuel injection control module accounts for about 70% of P0005 cases. The FICM manages fuel injection timing and can fail due to electrical faults or heat damage, disrupting the valve control signal. Damaged or pinched wiring harnesses can disrupt the circuit, often from vehicle vibration or improper installation. This creates breaks in the electrical path, leading to the open circuit condition. Addressing these issues promptly through inspection and repair is essential to prevent engine stalling or performance problems. Begin diagnosis by visually inspecting the wiring and connectors for the fuel shutoff valve. Look for corrosion, damage, or loose connections that could cause an open circuit. Next, use a multimeter to check continuity from the FICM to the valve. Set the multimeter to continuity mode and test the circuit. A reading exceeding 10 k ohms indicates an open circuit. Finally, scan for related diagnostic trouble codes to aid in diagnosis. Look for codes like P06111 indicating FICM performance issues or P0003 for fuel volume regulator control circuit problems. Repairing the P0005 code focuses on fixing the open circuit in the fuel shutoff valve control system. Common solutions include replacing damaged components and rebuilding modules. One common fix is replacing corroded connectors that cause the open circuit. Inspect and swap out damaged connectors to restore electrical continuity. Damaged wiring can create open circuits. Repair pinched or broken wires, or replace the entire harness if necessary. If the fuel shutoff valve itself is faulty, replace it with a new one to eliminate the open circuit issue. FICM rebuilds are a common solution for P0005 codes. Rebuild or replace the fuel injection control module to fix control circuit problems. After repairs, clear the diagnostic trouble code, and perform a road test to verify the fix and ensure no recurring issues. Modern diagnostic tools have revolutionized P005 troubleshooting with advanced features. The Bosch KTS1000 uses AI-assisted troubleshooting to identify circuit issues quickly. This tool reduces diagnosis time from hours to minutes by analyzing electrical signals automatically. The Autel MaxiCom provides real-time oscilloscope functions for testing valve actuation. It ensures high accuracy when checking the fuel shutoff valve control circuit. Circuit testers like the one shown help pinpoint electrical faults directly. Here's a simplified circuit diagram showing the valve control system. The ECM sends signals through wiring to the fuel valve solenoid. Modern tools use oscilloscopes to visualize these signals in real time, detecting opens or shorts instantly. AI integration in automotive diagnostics predicts failures before they become codes, enhancing overall accuracy for issues like P0005. These advancements make diagnosing and repairing P005 much more efficient and reliable. Real-world cases demonstrate how P0005 codes manifest in different vehicles. A 2008 Ford F-250 with 180,000 miles developed a P0005 code due to wiring harness damage from rubbing and FICM corrosion. The harness rub-through created an open circuit, while corrosion affected the fuel injection control module's electrical connections. Diagnosis revealed continuity loss in the circuit. Replacing the corroded FICM resolved the issue, costing about $800 with 2 days of downtime. This highlights the importance of checking both wiring integrity and module health. Another example involves an off-road Jeep with a modified 6.4-liter Power Stroke engine experiencing intermittent stalling. The root cause was voltage drops from a faulty relay in the fuel system circuit. Advanced scanning showed inconsistent voltage during operation. Swapping the faulty relay and resetting the code restored reliability, even in extreme off-road conditions. These cases underscore the need for thorough electrical diagnostics. Addressing underlying issues like corrosion, wiring damage, and faulty components prevents repeat failures and ensures long-term vehicle reliability. As electric vehicles become more common, the P0005 code's relevance is expected to decrease significantly. The bar graph shows the growing electric vehicle charging infrastructure market, highlighting this shift away from traditional diesel systems. However, support for legacy diesel vehicles will persist through advanced AI-driven repair applications that can diagnose and troubleshoot codes like P0005 more efficiently. Looking ahead, future diesel engines will feature integrated sensors for predictive maintenance, as shown in this image of smart engine sensors in a turbine factory. This technology could prevent open circuit issues and reduce DTC occurrences overall. These advancements represent the evolution of diesel diagnostics, moving toward more reliable and proactive systems.